Hi, this is Tim. Welcome to the corner. Today we have got this. This is the Relatively Universal ROM Programmer, and it's an open source project by Anders Nielsen, and you can check this out, the project, on abnielsen.com/65Arduino. It's designed as an Arduino shield, and here we've got an Arduino Uno Rev 3, and you see it will fit quite nicely the other way around. It will fit quite nicely on that. The board comes partially assembled with all the SMD components on here already placed, and it's got nice Eniga gold contacts, and all we need to do is add a ZIF socket and some headers. So let's build it up. The easiest way to fit the contacts into an Arduino and have them be sure that they will line up is to fit the contacts into the Arduino and then fit the board on top of it. So this is just a strip of 40 contacts. So we need to break these off to correspond with the size of the pin headers. So that's one. That's two. And that's four. These will come in useful for pin headers on other parts of the board. And then we simply drop it in, and you can see everything lines up perfectly. And so what we need to do is put some flux on and solder the pins. There we go, that's actually the components on the underside soldered in. So now we have some components to solder on the top side, and this is basically a few more headers. Okay, so on this side we have basically some pin headers. We need these are the programming headers. You can see underneath it tells us how to connect these for various programming modes. These, I think, are just basically test points, and these down here are test points. So we can put in one of those there, and we want 3 for here. And this is going to be an OLED header, which is slightly taller, so I'll worry about that later. What I'm going to do is just put some anti-static foam on here like that, so that we can turn it over, and then that will let us tack down. Then basically I'm just going to tack one pin and then have a check. There we go, so that's just a set of jumpers. That, I think, is a serial port. This is for an OLED. I've got a piece of strip here which we can put in for that. I don't have an exact 4 length one, so we have to just cut one down. There we go, like that. Right, and the final pin is there we go, and that is it. So there it is, all soldered up. We need some jumpers for the positions there, and we can just plug it into the Arduino. There we go, and then it just needs to be powered and programmed. So for a 28-pin EPROM, we want pin A going to 5 volts and B going to A13. That's A13. That's 5 volts. So that should be right. What we need to do, because if you notice we've got connections here which are basically our test points. And they could short out on that. So what we need to do is put some insulation on that. So this is just some electrical tape. There we go. So that should insulate these points from making contact. So there we go. In the time between then and now, there has been a mod to this board, and Anders Nielsen has released a video on it, and I will give you a link to that up in the corner and also in the description. Basically what we need to do is we need to add 2 resistors, and they go between this point, which is currently unconnected, and ground, which is these points here, and VPE, which is actually on that point there. Or we can also get it on this far end here and right down the other end. So what is this mod and why are we doing it? What we are doing is we are providing a voltage to pin 11 on the Arduino, which is an analog A to D converter, and that is going to tell us basically what our programming voltage is on the Arduino, and it can be anywhere between 0 and 36 volts. So we are using a voltage divider because the Arduino can only cope with 5 volts, 0 to 5 on the analog input. So what we are doing is a thing called a voltage divider, where we have R1 and R2, and the ratio of this and this, the actual values themselves don't particularly matter, but the ratio between this and this determines the voltage here as a percentage of the voltage here. So in our case we've got up to 36 volts at VPE, and we want a maximum of 5 volts here. And that gives us On the revised version of this, which you can see on the GitHub page, that gives 270k and 44k. We don't actually have those values, at least not easily, because we've just got standard value resistors. So we've actually got 330k and 47k. So that's V out. So the ratio of that gives us 270k over 44k, which is 6.13. And our ratio is 330k over 47k, which gives us 6.47. Now, since this is bigger than this, everything is fine. So where do we need to put the resistors? Well, we need to put them between, this is actually VPE is a point on here, that point there. This is pin 11, which is this point here, and this is ground, of course. So we need to identify, and I'll show you this on the circuit, on the circuit board layout. We need to identify VPE, and VPE is the track that starts from here, goes all the way along here, dips into here, and then goes to here. Pin 11, which is going to the Arduino, is this pin here, third one from that end. So that is our common point. And we have one resistor going from there to there, and one resistor going from there to ground, and ground is on these two pins here. So there to there, there to there. That one is going to be the 47k, and that one is going to be the 330. Let's set up the soldering iron. There we go, making a real bodge of this, but that is it done. So that will give us improvements for when we are running with an Arduino. And speaking of running with an Arduino, we have got some software, and we are going to install it right now. Now, in order to plug this into a Uno, we need a Uno. So here it is. This is just a cheap one made by AVRDUDE, because you can get two of these for the price of one. Sort of proper Arduino, if you like. But we get our power cable and our Arduino board. So put this on before I forget. There we go. The only difference I think is that it is black. So we can plug this straight in this way round. There we go. The OLED goes into the OLED socket. It's a bit out there, but never mind. We can invent a box for this to go in if we want. And then this is going to go into our laptop or power supply. And we have to program the Arduino in order to talk to it. So let's do that. For the programming, we are going to use my MacBook Air. Because it's only got USB-C, it is connected to my little external hard drive, which is actually an M.2 SSD, 2 terabytes, and that has a USB hub in it, which goes down to 3.1, 3.0, and so on. It's Thunderbolt 3. So we can plug this in. That goes into the Uno, and I have spotted we need to change this because, hopefully you can see this, the gap here between the top of the USB connector and the bottom of the PCB is pretty much non-existent. You actually can see air through it, so it's not shorting out, but in order to make sure it doesn't short out, I'm going to put some tape on there. This is electrical tape. Fold the sides over. I can trim that up neater at some future point. But there we go, and we know that that is not going to short out. So this can go into, that way around, the USB, and you see immediately it lights up, which I guess is the default. I'm not doing anything state. You can see, if you look inside, yellow LED is blinking. There we go, that is the default program that is on the Arduino, and so anything that is on there is just random startup stuff. So the software that we're going to use to talk to this is called FireStarter. And FireStarter is a Python app, and it will talk to the firmware that we need to download onto this. So the first thing that we need to do is install some stuff. This is the second time of doing this because last time OBS screwed up and I didn't get anything recorded. So I've got the Relatively Universal ROM Programmer GitHub page up, and this will tell us how to install software. So there is software for the board that runs on a companion board to this, which is called the 65 Arduino. We haven't got that at the moment, so we're looking for Arduino software. So there is a program called FireStarter, and this is an alternative firmware, and that's what we're going to install. It doesn't use the OLED, so I've taken that off. And to install this, we have to go through several steps. So FireStarter is a Python script that runs on the Mac and also runs on a PC. It is also a piece of firmware that runs on the Arduino itself. And in order to install the firmware on the Arduino, we have to install a program called AVRDUDE, which is what FireStarter, the Python script, will use to install FireStarter, the Arduino firmware, onto the Arduino. And in order to install AVRDUDE, we need to install Mac Homebrew. So that is going to be our base position. Let us start by installing Mac Homebrew. And to do that, we actually go to the Homebrew website, which is brew.sh, and we have a script that we need to run in the terminal program. So we can copy that script like that, launch the terminal. Let's open it up. You can see it's already saying no such, because I've gone through all this before and uninstalled it. So, right, that's the command to install Homebrew. It's going to ask us for our password. Don't look. Press return to continue. Okay, that's done. Right, so next steps. Run this command to install Homebrew in your path. Let's just copy that, paste it in, and run that. Run brew help to get started. And there we go, that's all the wonderful stuff for Homebrew. Now, we need to use Homebrew to install AVRDUDE, and to do that we type brew install AVRDUDE. And there it goes. That's done. So to install FireStarter, pip install FireStarter. And there we are, it's done. So we can run FireStarter now. And get some help. So FireStarter FW should tell us about FireStarter on here. Firmware version 1.0.13, you have the latest version. So now, before we can actually use this in anger, we need to do some configuration. And we need to have a look at VCC, just to check what it is. And that's telling us that VCC voltage is 4.76 volts. If you look inside, you can actually see it's directly talking to the Arduino, and we are getting information back. To get out of this, we need to go Control-C. We can also check VPP. So that's going to be FireStarter VPP. And that's telling us that the VPP voltage is 12.5 volts. Now, we're going to be looking at a 27C256 EPROM, which is an 8K EPROM. And the VPP for this is between 12 and 13 volts. So, that's kind of okay. I think it's actually 13 volts. We can tweak this by getting our screwdriver and adjusting the pot while we're monitoring the voltage. And you'll see it's now, that's pretty close to 13 volts. Control-C again to get out of that. Now, there's actually a step that I have forgotten, and we better do that, and that is to tell it what the value of these two resistors are, because it's actually these two resistors that are enabling it to get the VPP voltage from pin 11. And so we need to set that FireStarter config minus R1 is 3300,000, so 330k, minus R2 D2 is 47,000. And that has set the configuration. So it now tells us VCC is 5.06. So that's gone up a bit. So if we go and read VPP again, it's probably going to tell us something different. Oh no, that's close enough. 12.93, 12.89. That's about what it was. Okay. And we're going to look at this EPROM. This is a 27C256, which is 256K by 1 or 8K by 8. And this is a 1581 firmware ROM, 318045-02. We will have used this in our 1581 build video, which you can find on the channel. So put that in. We stick this in with the arse end at the bottom and pin 1 towards the lever, but pin 1 is not in the top of the socket. So in this instance, pin 1 is actually down there. So we can check the details of the EPROM by saying FireStarter info 27C256. Or we could if we could spell. And there it gives us all the information about the 27C256. And we can see it's an Intel, 28 pins, memory size 8000 hex, so 8K. EPROM, it's not erasable. If this was an EEPROM, then we would be able to erase it on this as well. And that VPP is on pin 1, so pin 1 is there, that is the VPP. There is jumper on the back of this that you can set. It's actually a solder blob that tells us whether we're using 28 pin or 32 pin EPROMs. You can't change between 28 pin and 32 pin on the fly. You have to move that solder blob. It's not a pin. So it tells us the jumper configuration, and yeah, JP3, which is underneath, it's got on the 28 pin version. JP1 and 2, which are these on the top, are configured for A13 and VCC. So there we go. So in order to read the EPROM, we type FireStarter read 27C256, and we're going to put it into downloads /test.bin. Real time, 3, 2, 1, go. That's it, about 7 seconds to read that EPROM, and we can have a look at the downloads folder and test.bin 33K. We have here a Jiffy DOS ROM, which we're going to burn into another EPROM in a moment. But let us have a look at what we read. So we saw, I'll just resize that slightly. So we saw test.bin. We can look at that with the xxd command. That is basically a binary file reader, and downloads /test.bin. And there is our 33K file. Whoops. Which we can scroll back up through. I can see copyright CBM. some names there. David Syracuse, software. Hardware, Greg Berlitz, dedicated to my wife Liz, I guess Lisa. And blocks free, so that definitely looks like a Commodore Drive ROM. Right. I think we successfully read that. Now I'm going to take that out and I'm going to get some blank EPROMs. So here are some blank 27C256 EPROMs. They are actually AMD, I believe. I'm not sure that that matters. So stick that in. There we go. Stick that in the thing. And we can do a blank check. So FireStarter blank 27C256. Chip is blank. Good. Let's just do a blank check on this other one. They came fresh out of the EPROM eraser yesterday, but it's always good to check. And it is blank, right. So I'm just going to stick that back in the foam. So we want to put Jiffy DOS onto this. Jiffy DOS 1581-6.01. So in order to do that, FireStarter write 27C256. Downloads slash Jiffy DOS underscore 1581 underscore 601 dot bin. Real time, because that's 6.01 dot bin. And it failed. Chip ID 0x110 don't match expected ID 0x898C. Okay, so I found out what this is. This is, and I will show you, thanks to Control-Alt-Rees and the folks at Anders Nielsen's Discord. We've got this list of EPROM IDs. So here is a list of EPROM device IDs as used in EPROM programming software such as XG Pro. So it said 0110. 0110 is, here we are, it's AMD, and we did observe that this was AMD, and it's an AM27C256. The ID that it said it was looking for, 898C, we can check that, I guess. 8, there we go, 898C is a D27C256, and that's an Intel. So I guess it defaults to the D27C256 rather than the AM. Let us just go back into here and do a FireStarter info on AM27C256. Ah, yes, now this is telling us AMD 13 volts VPP. Same pinout, same jumper configuration. So let us go back to our write command and change this to say AM27C256. Real time 3, 2, 1. That looks a lot better. And that's it done, 21.5 seconds. It does actually verify as it goes, but we can read that back and do our own check. So let's do that, and that's going to be FireStarter read. It doesn't worry about the ID, I don't think, when it's reading, but we will still say AM27C256, and that will go to downloads. Slash verify.bin. And then we go, it read it in 6.96 seconds, and we can see that verify.bin is on the screen. So once again, XXD, download slash verify.bin. We've definitely got a chip. It all looks sensitive, and we can see there copyright 1989 Jiffy DOS 6.0.158. So that is a Jiffy DOS ROM, and we have programmed it using an Arduino and command line stuff, and isn't that brilliant? Now, if you're interested in this EPROM programmer, I have a bunch of spares, and they are available on my eBay page. I'll put the link to that in the description. They're currently only shipping to the UK. There is also, I did briefly mention it, this which is called a 65 Arduino. And we're going to have a look at this in another video. This is a single board computer that is Arduino compatible in the sense that it will plug into an Arduino port. So we can take this off here and we can plug this into here and basically have the same thing going, except it's now running as a 6502 machine. These are also available on my eBay. We're going to be building one of these up and having a look at it in another video. It's a 6507, an EPROM, and this is a 6532 Riot chip, which includes RAM, I/O and timers. So if you've got this far, thank you very much for your patience, and please like the video, and if you haven't subscribed and you would like to subscribe to the channel, then please do so. If you want to support the channel in other ways, please check out my Patreon. The address is in the description. Thank you for watching. Please like and subscribe, all that stuff, and I will see you next time. See ya. Bye.